Hello, my name is Joshua. This is our Module 6 project for EAI 6010. And then the question we set out to answer is one almost every organization faces. When you want to apply machine learning, should you build something custom, or is there an off-the-shelf service that's already good enough? And our setting is a state motor vehicle agency, the DMV in most states. And here in Massachusetts, the RMV. They get a flood of resident questions every day, and each one has to reach the right unit. And we're going to test whether a free pre-trained NLP service can do that routing, or if it can't, and what should we do instead. And the problem. So motor vehicle agencies receive more email, web form, and phone questions than the front desk can sort by hand. Every message has to get to the right unit: licensing, registration, real ID, appointments, or fees. And before any agency pays to build and train a custom model, there's a cheaper first question worth asking. Is there any existing NLP service that already does this well enough, or off-the-shelf services are free and instant? Custom models cost time, data, and money, so the real open question is the one this project tests, is whether a ready-made service can handle the hard regulatory questions or only the easy operational ones. Our goal is to measure a pre-trained service on a realistic set of inquiries and then recommend it and keep it and move it to auto machine learning or build a custom one. And so to test it fairly, we wrote a data set of 50 resident inquiries and labeled each one with the unit it should reach. The synthetic data set for the whole project is reproducible, and there are no copyright issues, and they are spread across 5 units. You can see here licensing is the largest at 14, and then registration, real ID, appointments, and fees. The important design choices in that last line. 8 of the 50 are deliberately hard, multi-topic, and ambiguous messages, like if someone asking to renew their license and asking about the wait time in the same breath. We included those on purpose because a test set made only of easy questions would flatter the surface instead of stress testing it. And here's the surface we chose. It's the Hugging Face Zero Shot classification pipeline, running a model called BART Large MNLI, and Zero Shot is the key idea. We never train it. Instead, we give it a 5-unit names as plain English descriptions at runtime. In the model, which was pre-trained on the language inference task, scores how strongly each inquiry implies each label. We picked it for 3 reasons. It's completely free and no API key, no training, no labeled data, so any classmate can reproduce it on a laptop. The categories are defined in plain English, so adding or remaining a unit is one line change. It's easy, and it's the honest buy before you build baseline. The first thing a real team would try before spending money. And how it works. So mechanically, it's a short pipeline, and inquiry comes in, we hand the model our 5 units as candidate labels, and then short hypotheses like a real ID or federal identification question. The model scores how well each label is entailed by the message, and then the highest score wins. So inquiry get routed, and then with the confidence number attached, it's like 61%. The thing to remember here is this matters in a minute, is that it's matching language patterns, and it has no built-in knowledge of state-specific terms like real ID, RMV, or excise tax, and it only knows general English. So, yeah. Here comes our teammate.
Hi, my name is Hyunjin Kim Elizabeth. I'll be explaining the working demo here. So this is the output from the demo script that's captured ahead of time. I'm not running it live currently, but it's still from a real run, and it reproduces within a single command. And first, a quick reminder of what's happening here under the hood is that, again, this is a zero-shot classification, so the model itself is never trained on these 5 units, but instead these were it takes each of these inquiries and scores it against the short plain language description of every unit, and then it routes to the best match, which is like the score, the confidence that you see here. And you can see it gets straightforward ones right and correctly, like the license expiration question goes to licensing, private sale title goes to registration. But if you look at the third line here where it says licensing appointments and wait, it should go to real ID originally, but instead it lands in licensing. So the last line also where it says licensing, it's a multi-topic case where it's asking to renew the license and the wait time, but it picks just one of the units and just drops the other half. So even if this is like a small sample preview where the server service kind of struggles a bit. Next is the results on the 50 inquiry set that we had. The numbers across all 50 inquiries, these are like the first chunk of sets that we tested. Overall accuracy for the whole model is about, for this one specifically, is 68% with a macro F1 around 0.68, and that balances the performance across all of the 5 units regardless of the size, but a single accuracy number hides the real story, which is in the confusion matrix that you see on the right. And the diagonal that you see is the correct routing. And the cell that jumps out is the real ID. And of the 9 real ID questions, specifically, the 4 of them went to licensing, and that one confusion is the single biggest source of the error. So the headline itself isn't like 68% if that's the errors are concentrated into one explainable specific place. So where it breaks, strong on operations but weak on regulations. The breaking accuracy down by unit makes the split obvious. The operational units, they do well, especially when it comes to appointments and the wait times. As you can see here, green on 88%, the fees are at 75% and the registration's at 73%. And these use distinctive everyday language, but the real ID here, red at all the way down at 44%, it's worse than the probability of the coin flip for that category. So the service is strong on the operational questions and weak on the regulatory one, if we see it, and that's not random noise, it's just a structural and clear pattern that we see. So why it fails, like why does it fail here based on our model? Like here are 3 real misroutes in all of them. A real ID question is sent to licensing, and here like this has been the root cause consistently as it is. It's straight from how zero shot works, as the model has no training and examples yet. When it comes to real-time data, of course, that's classified. But the only thing it can go from here from the synthetic data set is how well the words in the inquiry match the words in the unit descriptions. And the real ID question and the ordinary licensing renewing questions, they share almost all of the same words like license, renew, ID, address. So you can't really tell that the real ID is a separate federal program with its own requirements, and also it's something fairly new. So half the request is lost, and these are the limitations when it comes to the zero-shot approach itself, and it's not about the bugs that could really patch. So we ask, what about the performance? Like, is it still sufficient? Is 68% accuracy is still good enough in this case in our synthetic data set? And For us, we say the honest answer is that it really depends entirely on the decision of the routing support. So yes, when it says for human triage, like if there's a human clerk that would review that these different routings, and if there's a service that just drafts the first pass queue assignments, and for someone to just look at and just route different people to different lines or different places, then yes, it's absolutely a real-time saver. But because it's a misroute, it's also cheap to fix. But if you let it run unsupervised, it's an auto answering residents or closing the tickets with no human review. And no, then we wouldn't say that the performance then is sufficient. It's confident that real ID errors would send people the wrong requirements at exactly the moment correction information matters the most. So this is not what we want to rely on. And sufficient isn't a property of the model usually here. It's more about the property of how we're deploying this and how we're going to use this for our advantage. Yep.
Thank you, Elizabeth. Now on, I am Abhishek Singh and I'm going to continue. So that leads to our recommendation, and so it's a stage one. So first, we are keeping it a free service for now for a human review triage, and while we collect labeled inquiry logs. So the second one is the main recommendation. We're gonna move to automated machine learning model. So because of the failures which are concentrated and explainable, so there would be a vocabulary and terminology mismatch. So the third one is we're gonna move to Google Vertex Azure, which allows us a fine-tune a strong classifier on our own examples without hand designing a model. So it learns the real ID versus licensing boundary and our state specific terms. So we would like to hold a custom model in reserve, which would be only worth if it's an automated machine learning plateaus. Or we also need to multi-label routing, which can't express. So like because of its cheapest labor that targets the actual problem. And the next slide. So there's a pros and cons in this. Quickly, the trade-offs side by side, and zero cost, zero training, plain English characters. These are the pros, and on the cons, it's a confusing real ID with the licensing, and which has no knowledge of state-specific terms like RMV or excise tax. So it forces multi-topic messages into one unit, and its confidence score isn't calibrated to its domain. So it's a strong starting with clear and known ceiling. Next slide. So the lessons we have learned for now is the first one is accuracy alone, which hides failures. We have to slice by category, or one weak unit disappears into a decent looking average. Second is like sufficient, which depends on either human reviews with the output. And the third is the automated machine learning, which is into a domain data specific, which is cheapest fix for the terminology mismatch. And on the right, the whole thing which reproduces in 3 commands: install the requirements, run the demo, and run the evaluation. Everything we have shown which regenerates from those. And at last but not least, we gonna wrap up with like 3 takeaways. One is a free strong start with a zero shot service routes, which is an operational questions at 75 to 88% with no training at all. And the second is not sufficient but alone. It can't separate real ID from licensing, which is a risky and unsupervised routing of regulatory questions. And the third is the automated machine learning model, which is the next step, which is a fine-tuned agency's own label log to learn from its own terminology as well as the mistakes, and to keep the custom model in reserve for the hardest cases. So for now, thanks for watching. We are happy to take any questions.